Welcome back for another Ansys Fluent module. Today I'm going to go over Ansys Fluent, as well as modeling flow over a cylinder, showing you how to create an animation file, and finally showing you how the von Karman effect looks like. In fluid dynamics, a Karman vortex effect, or a von Karman vortex street, is a repeating pattern of swirling vortices, caused by a process known as vortex shredding, which is responsible for the unsteady separation of flow of a fluid around blunt bodies. The animation shown in the screen is just an example of the von Karman effect. So, to get started, open up Workbench and drag and drop Fluid Flow Fluent module onto the Workbench schematic window. Here we are going to rename this to Flow over a cylinder. Hit Enter. And then the geometry selected, we are going to change the analysis type to 2D to simplify the process. Then we are going to go ahead and double click on Geometry to open Space Claim. We have to wait for Space Claim to load. Once that is loaded, we're going to go ahead into the Sketching tab and click on the Z to face normal here. I'm just going to change the units to meters as the default length is in millimeters. I am drawing a rectangular shape of 15 meters by 30 meters. And a cylinder of 1 meter in diameter. Then I'll just delete the circular part. Now you can close Space Claim. Note that you do not need to save anything. Ansys Workbench will take care of that for you. Back in the Ansys Workbench schematic window, double-click on Mesh and wait for that to load. Once the mesh window is open, you can see that the default thickness is 1000 millimeters. Do not worry about that one, since we are doing a 2D problem. Or you can simply change it to 0. We are going to create a mesh just to see how it looks like. The mesh is obviously too coarse. We want to have a bit more detail around the cylinder. So what we are going to do is, we are going to change the mesh generation method. Select your fluid body, and we are going to change the target element method here to triangle element. We are going to add the element size around the cylinder. Now we are going to change the element size. Use the edge selector to select the edge. We are going to change the element size to 0.025 meters. If you want the results to be more precise, I was just going to go with 0.01 meters. We are going to go ahead and right-click and generate mesh so that you can see now we have a much more refined mesh around the cylinder. However, the mesh is not really uniform, and for the von Karman effect, it is better if our elements are actually uniform around the cylinder. So what we are going to do is, we are going to add more elements in. Right-click, Insert Inflation, and then for the geometry, we are going to select the fluid domain. Apply for the boundary we are going to select. It is already on Edge Select. We are going to select our cylinder, apply the inflation mesh generation for the cylinder, we are going to put first layer thickness, and for the first layer height, we are going to keep it the same value as the edge sizing, which is 0.025 meters. We are going to put 40 layers and have a growth rate of 2.5. Once that is done, go ahead and click Update and click on Mesh. There you have it. So now we have a more uniform mesh around the cylinder. We are going to just change mesh size of the global measure. This is too coarse for our analysis. Therefore, we are going to go into mesh sizing and then over here. And the max face size we are going to put is 300 millimeters. Then we are going to update. So there we go. That is perfect. Next, what we are going to do is we are going to create named selections. Select two horizontal edges and create name selection. Name it as Wall. Select the cylinder and also create name selection, and name it as Cylinder. Next, select one of the vertical edges and create name selection. Name it as Inlet. Finally, select the last edge and create name selection. Name it as Outlet. Once you have that, we are ready to go to the next step, and we are going to update the mesh. So right-click on the mesh here and update. This will take a few seconds. And then we are going to launch Setup. So double-click on Setup. This will launch the Fluent launcher. We want double precision for this analysis. And as I have 4 processors and 1 GPU in my computer, I'm going to enable that to compute a bit faster. Now we are loading Ansys Fluent. We are going to go and keep the solver as pressure-based and change the time to transients, seeing as the von Karman effect is a transient effect. Next, we are going to change the model to a viscous laminar. For the material, we are actually going to change this, and we are going to make this simple. You could also go into a Fluent database and you could choose, for example, water, and you can click copy, and then it would add water as your fluid. But as I am in here, I am just going to do it really simple. I will call this fluid, and I'm going to put the density equal to 1, and the viscosity also 1. This is just to make everything simple. Click Change, Create, and then Close. So now it is called fluid with viscosity equal to 1. Anyway, we want basically a Reynolds number of 80, so keep everything simple by having the fluid density as 1 and viscosity as 1, and keep the fluid velocity equal to 80. So, for our boundary conditions, because of the name selection, it already imported the cylinder as a wall, the inlet as a velocity inlet, the outlet as a pressure outlet, and the wall as wall. So that is the importance of naming our selections beforehand. So we do not have to change the names any further. The only thing we have to change is the inlet, and we are going to click on Inlet, Edit, and we are going to add a velocity magnitude of 80. So we want 80 meters per second flowing inside. Click OK. So click that solution method. We are going to put second order implicit. Next, reference values. This is for the initial solution. Initialization, we are going to compute from the inlet and for the monitors, we are going to create a lift and drag monitor. Solution initialization. We are going to do a hybrid. Click Initialize Calculation Activities if you want to generate the movie animation, which we do. We want it to save the calculation at every step. So we are going to put this to 1. Then we are going to go to Run Calculation. Insert at a step size of 0.01 and maximum of 250 and a max duration of 50 if you want something more precise. 0.01 will give you a much more accurate solution, but I'm going to put 0.1 and then we are going to calculate for now. It is going to start solving the problem. I'm not actually going to wait for this to solve because I already have the solution. But what will happen is that these are your residuals, which will never really converge. And the solution is going to alternate up and down, up and down, up and down. This is because of the von Karman effect, and the solution is a transient solution. The point is that the solution will not reach a steady state. I will now show you the finished results. Double-click on Results. When you double-click on Results, it'll open CFD Post. What we are going to do now is we are going to add a contour plot. So we are going to hit on Contour, click OK, and then here we are going to put Domain as the surface body. And location is a symmetrical one. And what we want to see is the velocity in the X direction. Click Apply. We have our velocity profile after a certain time. That is actually at the end, so if you want to change the time, you can go to Time, Step Selector, and you can show, let's say, I want to see at 2.5 seconds. That is what the flow would look like at 0.1 and after 2.5 seconds. You can change it using the Time Step Selector if you want to get better quality of the contours. Instead of using 11 as the number of contours, you can use, say, 200. Hit Apply and there you have it, a much smoother image. You can also change the contour to display the pressure. Anyway, we are just going to keep it in velocity index for now. If you want to add a streamline, we can go ahead and click on Streamline. As you can see, the von Karman has not really shown yet after 0.3 seconds. But after some time, it is really showing the effect. We are just going to uncheck Streamline, go back to our contour, and to create the animation now. What we are going to do is to reduce the number of points to 20, because this is pretty intensive on the machine. Click on Animation, and choose Time Step Animation. Tick on Save Movie and choose the location to store the file. There you have it.